Hello everyone, and welcome to the first lab of our new unit. In this unit we're going to look at how to describe a new kind of motion. Being that we're completely online, that new kind of motion is what we will see in a Pivot Interactive called the dry ice puck on a ramp. So if you look at the video down here, you see this dry ice puck which is hooked up here by a little wire. Wire gets cut and the dry ice puck will move down the ramp. There's actually a nice little video inside of the Pivot Interactive you're going to do that shows you how they make the dry ice puck, and it's just kind of interesting. But what I want you to do here is to watch this dry ice puck and try to answer this question. What's different about this motion than the kind of motion we saw in the toy car lab? So here we go. Watch this. It'll play a couple of times. Ooh. So check out that motion again and think about it, what's happening here. So hopefully you're noticing that what seems to be different here is that we're not moving at a constant velocity. Rather, the dry ice puck is speeding up as it moves down the ramp. Right? Now, yes, there's another term for this that we're going to build, right? And we're going to use in this unit once we get there. Okay, but for now, we're just talking about velocities and things, and we know about, we can talk about speeding up, which is getting faster, and what that means, right? So this is the pivot that we're going to do. Talk about some of the instructions and things for that, but we're going to treat this much like we did with the Toy Car Lab, in that we are going to be comparing the position the puck reaches in certain amounts of time. So our variables here are going to be position time variables, and we're going to build from there into some other ideas, right, in order to describe this motion. So the purpose of this lab is to create graphical and mathematical representations of the relationship between the position and the time for the dry ice puck on a ramp. Now, you may want to print off the lab sheet at this point so you can kind of follow along with what we're doing. But all the instructions we're going to talk about in things with the pivot are on the lab sheet, and they're within the pivot itself. So you should pay special attention when you're doing the pivot to the multiple choice questions. Make sure you're doing all of them. Watch the movies, do the first part, which is going to help you learn what kind of measuring tools you have. You have a ruler, which is like a meter stick, and a stopwatch, right, that you can use inside of the program. And so those will allow you to make the position and time measurements as we go. Right? So you're going to log into Pivot Interactives, and of course there'll be a link for this in the schedule sheet for this unit. And you're going to open the activity called Dry Ice Puck on a Ramp. Right? There will be other activities listed there. Right? One of them is the one we just did, and the Newton's third law one, and then, the two Newton's third law ones. And then there's a couple that were for online people previous to this that you don't need to bother with. Please make sure, like I said earlier, you do the first section, which is called Getting Started, because that's going to explain how you're going to use the stopwatch and the ruler in order to measure things within the video. And in fact, it's going to ask you some questions, some little multiple choice questions, which you need to make sure you get right, because that means you're using the equipment correctly. Then, once you understand how to use the equipment, you're going to measure the position of that puck every 0.1 seconds. So you'll see on the data sheet it goes 0, 0.1, 0.2, 0.3, 0.4, 0.5, right, all the way up to, I think, 0.9 seconds. Okay? Anything past that doesn't, it gets to the bottom before then. Okay? And you're going to measure the position with the ruler thing inside of it for each 0.1 second and see where it is. Right? Then you're, of course, going to make a graph. Now, in this case, since we're choosing 0.1 seconds to be our time increment, that makes time our independent variable. It's the one we are controlling. And therefore, we will measure the position, which is the dependent variable. Certainly, we could do this the other way, right? We could choose positions and figure out how much time it took, right, to go maybe 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters. Really isn't any harder with the equipment, but I want to do it this way mainly because as we did with it matches what we did with the Toy Car Lab, and also it'll help you create the same kind of graphs. Since time is the independent variable, it'll go on the horizontal axis, position on the vertical axis, and by the way, this should be centimeters, not meters. Right? You'll see that on your lab sheet that we're going to do this all in centimeters because that's what you measure inside of the program. So this will be a graph of position versus time. Now, if you remember, our position time graphs for constant velocity motion, the Toy Car Lab and beyond, right, were linear diagonal lines. Well, in this case, the velocity is changing. Because the velocity is changing, you're going to get some sort of curve on this graph. Right? And then, of course, remember that what you do when you get a curved graph is you linearize. So this is going to be a process going to use a lot of graphical analysis, right, for you to graph, linearize, all that stuff within the program. And it'll be handy for you if you can, if you're doing this on a laptop or a computer as opposed to maybe your phone or something, if you can save the file once you've made the graphs, right, it might save you some time setting things up in future things that we're going to do here. Right? If you can't, it won't be a big deal. You can just type your data back in again, all right? You know, change the column headings, all of that good stuff. So follow the instructions inside the pivot, and then all those instructions are also on your lab sheet to kind of help you out. Collect the data on the lab sheet, right? Then use graphical analysis to graph. Follow all the instructions on the lab sheet. Right? You'll be getting a grade for doing the pivot. You will also be getting a grade for doing the lab sheet, which you will upload. Right, so enjoy the dry ice puck on a ramp pre-lab. Right, hopefully you get that done. Then you'll come back and watch the movie on the post-lab right away.